All right, this is going to be a review of graphing 6 of our most basic functions in algebra. So what I want to do is just talk you through, if we were going to graph these by hand, what would we do? And so the first is the identity function. That's where the y values and the x values are equal. And so what we often do is we pick out different x values and see what would happen when they're put into the function. So in this case, the y values and the x values are equal. So if I look at all these values that I just put in here, I could take these and just copy them over because they're the exact same values. And so when I graph them, I've got -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. You can see it just going to go on forever and make this perfectly straight line. Okay, so that's our identity function. You'll notice that its domain and its range are both all real numbers from -infinity to +infinity. It's what we would say is symmetric to the origin. If we're reviewing what we talked about last time, because any point in there that we were to look at, for example, if I were to look at the point 2, 2, which is right here, if I change the sign of both numbers, that becomes -2. -2, that's also on the graph. So it's a reflection over the y and then the x-axis. So it's symmetric to the origin. And one last thing we could say about what we learned last time is that it is an increasing function over its whole domain. Okay? So what we'll look at later in the unit is how to modify this, and really all of Algebra 1, whenever you graph something in, say, slope-intercept form, you're looking at variations of this graph where you're shifting it up, you're shifting it down, shifting it to the right, shifting it to the left with different intercepts, or you might be looking at this function and rotating it, okay? Changing its slope, making it slope of 0 or a negative slope. Okay, so that's kind of what we're going to do, is look at how to change these graphs. So our second function is the squaring function, right? Or x to the second power. Remember that the reason we call it the squaring function is because if you take a number times itself, just a moment. Yeah, if you take a number times itself, 3 times 3, it gives you the area of that square. So that's why we say we're squaring it. So our squaring function, y is equal to x times itself, or to the second power. And so think about what we did last time. We plugged in values for x, like -2, -1, 0, 1, and 2. Okay. Now this time, to make those values into their y values, I'm going to take each of these values, but what I've got to do is I have to square each one of them. So 2 squared, 1 squared, 0 squared, -1 squared, and 2 squared. Right? So we end up with 4, 1, 0, 1, and 4. Okay. So when I graph those, it's going to look a little different. So -2 is going to come up to 1, 2, 3, 4. -1 to +1. 0 is still at 0. 1 is at 1. 2 is at 4. And I get this curve that we call a parabola. Okay. A couple of observations are that this time our domain is still -infinity to +infinity, because it includes both negative and positive values of x, but our range is only 0 to infinity. And so when we think about the range there, why is it 0 to infinity? Well, because the values of y on this graph are only that top portion. The other thing you'll notice is that the right side over here is an increasing function from 0 to infinity, and the left side is decreasing from -infinity to 0. And so how can we explain that? Remember that if I take any point on this graph, as I move from -infinity to 0, the y value of that point decreases. It gets smaller and smaller and smaller and smaller until I hit 0. But then from 0 to the right, anytime I move to the right, the y value gets bigger and bigger. It increases. So that's our increasing and decreasing. And we would lastly say, just in review last time, that this graph is symmetric to the y-axis. Again, you can see that it is reflected over that y-axis. You could see left and the right side are a reflection of one another. And so again, what we will do here is when we look at graphs of x squared, they'll shift up and down, or right and left, or some combination of both. Or they might even change their size. They might become, I don't know if it will allow me to distort this. I don't think it is. But you could make them wider or more narrow. Okay, so that's the squaring function. So now we have, next is the cubing function. And again, it also gets its name from geometry, where if you take a cube and you multiply the length times the width times the height, that gives you the volume of the cube. All right, so here's our equation. Y equals x to the third, or x cubed. And we'll start with the same x values, -2, -1, 0, 1, and 2. And once I have my x values, I'm going to think about what would happen to those values if I were to cube each one of them. Okay, so -2 cubed is going to give me -8. -1 cubed is going to give me -1. 0 cubed is still 0. 1 cubed is still 1. And 2 cubed is 8. And so those are my points. And you'll notice this time that the negative values are still negative. So -2, 1, 2, 3, 4, 5, 6, 7, 8. -1, 1, 0, 0, 1, 1. And +2, 1, 2, 3, 4, 5, 6, 7, 8. And so this, it's like a little bit of a parabola on the right, and then it goes in the negative direction to the left. So this is more like the identity, in that its domain is -infinity to +infinity. Its range is also negative to +infinity. This one, like the original, it is symmetric to the origin. And so what that means is if we were to take any point along the graph, say for example this 2, 8, which is up here, if I change the signs to -2 and -8, that point is also on the graph. So it's reflecting over the y-axis and the x-axis, or has symmetry to the origin. This function is increasing over its whole domain, so from -infinity to +infinity. Okay, and that's our first 3 graphs, and then we'll stop here, and then I'll make another video for the next 3.